I'm Theo, Director of Stack Audio Limited. So it's no secret that vibrations have dramatic effects on the sound quality of turntables. We started developing upgrades to help remove unwanted vibrations from turntables around 10 years ago, specifically for the LP12 Sondec. Our latest product was the Alva EQs, and these are system isolators that sit under turntables and other equipments that basically isolate the equipment from unwanted external vibration. But because turntables are so susceptible to vibration, we really wanted to take it to another level. And this is where we started looking at developing our own mats. Now, at first we started prototyping with different materials like felt, cork, rubber, carbon fiber, aluminium, and we also tried combining them all together, and we got mixed results, but none of them had a dramatic effect to the degree that we wanted to put our name on the product. It felt like we hit a brick wall, because at the end of the day, with a record mat, at absolute maximum you can have 5mm thickness, and that's pushing the boundaries. So there's not really much material there to absorb the vibrations. One day I was around a friend's house, and his kid had this little silicone popper toy. And in that moment, it kind of struck me, and it seemed like an obvious idea at the time, but to add compliance and to add elements of absorption into the mat to basically add stiffness or compliance to the mat to absorb vibrations further. And we mocked up multiple different designs, and we noticed the difference in sound quality from all these varying aspects of the design was quite staggering. And at this point, I realized that the process of getting the perfect mat was going to require advanced mathematical modeling. And that's why I reached out to Resident Engineering.
So when Stack Audio reached to me to work on the new idea for a record suppression mat, we had a challenge. We didn't know whether to only utilize damping for the concept or whether to also introduce more active elements. We know that the competition, they primarily use damping only, so they used monotonic material as their mat, which delivers the damping, and the primary effect of the damping is that it reduces the amplitudes of the resonant frequencies. However, we know that this doesn't reach the full potential of the vibration mitigation, because what competition doesn't do, they do not use the stiffness, which has a potential to isolate the vibrations much more effectively. And so we started looking on the concepts how we could introduce stiffness into the mat. For our record mat, the pads, the active mats, deliver the stiffness, and the material delivers the damping. In order to do that, we needed to introduce some flexible elements, and we had a challenge that we weren't able to find an easy concept that can be fit into a very thin plate. And so Stack Audio came up with the idea of an active pads that we tuned using a computational analysis to be just enough flexible to deliver the vibration isolation that we needed to, and we coupled that effect with the damping provided by the silicone material itself. And these two effects combined, so the effect of stiffness and the effect of damping, delivers a higher overall vibration mitigation compared to the pure monotonic mat that only has a damping. So when we progressed the design, together with the Stack Audio, we figured out we want to use the concept of springs. But then we didn't know how stiff those springs should be, how many of those springs should be distributed on the record player, and how big they should be. And so in order to find all those parameters, we perform a computational analysis. That computational analysis is based on the final element method. So we essentially modeled the entire system. So we modeled the record player, we modeled the mat, different concepts of the mat, we modeled the record. And what we were interested to see, how vibration propagates through the record mat, and we were measuring the vibration that is being seen by the record and consequently by the needle that records the music. And our design objective was to minimize that vibration by positioning and sizing the springs in an optimal way. And we started measuring to map out the space of what the excitation might be. The way how we did it, we measured a number of combinations of different mats and stabilizers on different records, and we got a huge set of measured data which tells us on what frequencies we see what amplitude, and then we enveloped them, so we draw an upper line across all of those. We found about 29 different configurations that we explored computationally. And based on those 29 different combinations, we created a response surface. So basically, we mapped out how our design parameters are influencing the output being the vibration that the record player sees. So even with some margin for error, what we used for our design was the worst case vibration that we can realistically expect to see on any given record player of any other customer. And what it allows us to do is that it allows us to design a record mat that should reliably work for whatever excitation potential customer might have, not only for one specific case of a record player that we happen to have in our lab. A unique part of the record mat design that we have developed is these pockets, which we call vibration pads. So there are 4 places around the record to which we focus all the weight. And at first this seems counterintuitive, because intuitively we would like to evenly distribute the weight on the entire pad. But if you do that, you are not able to harvest the power of the stiffness. You are not able to harness the power of the active vibration mitigation element that we specifically designed into. That is why we have these small raised nips on our record mat, which allows us to position the record on those nips, and by doing so the weight is focused into our active spring elements that then they deliver the vibration absorption. These stiffness pads are strategically placed in the positions that minimize the transmission of the vibration between the record player and the record, and they also facilitate lowering the vibration on the record surface. And what it does as a consequence is that the needle is not excited by the vibration of the record surface, and therefore that increases the quality of the music. Not only we simulated the response of our design, we also included a few standard designs that are available on the market. And as you can see from the graph, our design clearly outperforms the other designs. And that is because, unlike the other designs, we use the active vibration through the stiffness pads, compliant pads. What it allows us to do is to achieve vibration of the record that is overall lower than while using other mats. So once we went through a lot of combinations on a computer, we figured out which one would be most optimal. We had it made, we tested it, and we measured it to confirm that the vibration is indeed being minimized very significantly, and the quality of the produced music is therefore increased.
So the music starts when a needle goes into the record groove, and external vibration changes how that needle reads the groove. And as a business, we feel really passionately about removing those vibrations to reveal extra detail in the record. And we want to get the best out of someone's product by creating an accessory that enhances and brings out more characteristics of their turntable. We could have easily launched a simple mat, but we really wanted to take it a step further, because at the end of the day, for us, it's about longevity, and we want to deliver customers products that make a huge difference, because they'll come back to us and they'll have far much more musical enjoyment from their records.